Hello guys, first of all I welcome you all to this interview question series. We are in the Tableau Interview Question Series. We have already completed 2 sets and we are in the set 3 continuing with the data trend. So let's get started. The first question of the today's session is what is the difference between the parameters and filters? Okay, so first of all, what is filter? Filters are nothing but an applied condition where our data is filtered out. Okay, it's a very straightforward functions in which we get the data which is required for our analysis. There are various UI options available for the filter like drop down, list, check boxes, slider and something like that. Filters are nothing but the criteria in which we can do the analysis for. So it's a simple definition of filters. On the other hand, parameters is like a variables which can hold some values and perform some calculations dynamically. Okay, so if I wanted to create a parameter which holds the value of something like top 10 categories, and then we will just wire this up into the filters to do some dynamic calculation with respect to finding out the top 2 category, top 3 category, top 5 categories, something like that. So if you want to dynamicity into the calculations, we will go with the parameters, and this is the basic difference between the parameters and filters in the Tableau. Okay, let's move forward with the other questions we have. Explain how many types of filters are available in the Tableau. Okay, there are wide range of filters are available in the Tableau. Okay, so first of all, filters are used to provide the correct information to the viewers after removing unnecessary data. There are various types of filters available in the Tableau. So first one is extract filter. Extract filters are used to apply filters on the extracted data from the data source. For this filter, data is extracted from the data source and placed into a Tableau data repository. On the other hand, the second type, data source filter. In the data source filter, which is same as the extract filter, they also works on the extracted data set, but the only difference is that they works both on the line and extract connection. Clear? On the third filter we have a context filter. Okay, context filters are applied on the data rows before any other filter applied. They are limited to views, but they can be applied on the selected sheet. They define aggregation and disaggregation of data in the Tableau. Next we have a dimension filters. Dimension filters are used to apply filters on the dimension on the worksheet. Dimension filters are applied through a top or bottom conditions, formula and wildcard operator, something like pattern matching. Okay. Next we have measure filter. Measure filters are applied to the value present in the measure, same like a dimension filter. Next question we have differentiate between tile and floating in dashboards. Okay, in a tiled layout, item don't overlap. The layout will adjusted according to the dashboard size. In a floating layout, item can be placed on same other layers. Floating items have a fixed positions and sizes. So basically, if you want to adjust the visual based on our requirement, then we can use the floating. Or if you want to adjust the visual based on the total area we have and the total visuals we have in the report, then we can use the tiled one. Okay. Next, categorize dimension in Tableau. Okay. Dimensions are divided into 9 various categories. Okay. So first one is slowly over changing dimension. Okay, the value of the dimension changes over an amount of time for slowly ever changing dimensions. Okay, so over the time, if the value of the dimension changes slowly, then it's called a slowly over changing dimension. For example, students of worker, we can take that example as well, or we can just do something like a quarter wise total sales. So it's change in every 3 months, so it's called as slowly changing dimension. Then we have a chop ever. Okay, so this is a chop ever changing dimension. Value in the dimensions is rapidly changing for a chop ever changing dimension. something like an age. Okay, then there is an unchanged dimension. Values are constant or unchanged in this dimension, such like traffic signals. Then we have a shrunken dimension, right? Shrunken dimension are the set of dimension terms as a 1D pattern. Okay, so a week of shrunken dimension for a month. So this is the example for the shrunken dimension. Then we have a junk dimension. Junk values are unrelated dimensions are termed as a junk dimension. These are some of the various type of categories of dimension we have with respect to the Tableau. Next, we have a confirmed dimensions as well. If any dimensions is provided by a various business areas, then such dimensions are termed as a confirmed dimension, such as time 9 to 5 for any company or hospital or college, termed as a confirmed dimension. Then we have degenerated dimension. Degenerated dimensions have a primary keys only without any matter of info, right? Then we have role enjoying dimension. If one dimension is employed in a multiple roles, then they are termed as a role enjoying dimensions. For example, date for e-commerce site, order date of orders, or we can say that date of shipment, date of delivery are the role enjoying dimensions. Then we have inferred dimensions. Empty dimensions are also inferred dimensions. They are usually used in ETL, extract, transform and load. For example, customer email which he may not enter while submitting any form will be filled as a null, called as a inferred dimension. Next question we have, what is VSQL in Tableau? Okay, so VSQL in the Tableau. So VSQL is a visual inquiry language. Okay, so it's a visual inquiry language. It is a combination of a Viz and SQL. It's similar to SQL language, but instead of SQL command, the VSQL language converts data queries into a visual image. So this is the VSQL language, which is a combination of visual and SQL, visual query language. Next, explain the disaggregation and aggregation of a data in the Tableau. Okay, aggregation, the process of summarizing data and weaving a single numeric value called aggregation. Okay, for example, sum, average, mean, max are some of the aggregation operation we have. So what is aggregation? The process of summarizing a data and weaving a single numeric value called aggregation. Then what is disaggregation? The reverse process of aggregation, the process of weaving each transaction for analyzing all the measure both dependently and independently. For example, individual salary transaction for each employee. So these are the difference between the disaggregation and aggregation in the Tableau. Next question we have, state the components of dashboard. Okay, the dashboard consists of 5 components. First is web. It consists of web pages embedded into the dashboard. Second is horizontal component. It is a horizontal layout container in which we can add objects such as visuals. Then there is a vertical component. It is a visual layout container in which we can add objects similar to horizontal component. There is an vertical component is also there, and we can also add objects something like images, slicers, filters. Okay, then we have an image extract. Okay, it allows you to upload an image to a dashboard from a computer. Then we have a text. It is a small word pad where we can format and edit text. Okay, so next question we have for the day, differentiate between the discrete and continuous data roles in the Tableau. Okay, so first of all, discrete data. Let's talk about the discrete data we have. Discrete data roles consist of the value that are separate and distinct. Discrete data value can take individual value within a range. For example, cancer patient in the hospital, number of threads in a sheet, state. Discrete values are displayed in the blue icons in the data window and blue peels in the shelves. Okay, discrete data field can be stored into the dimension measure. Okay, then we have a continuous role consists of any value within the finite or infinite intervals. For example, age, unit price, order quantity. Continuous values displays as a green icon in the data window and green pill in the shelves. Okay, continuous fields cannot be stored and can be maybe you find this type of data into the measure field. Okay, next question we have for the day: what is the difference between the traditional BI and Tableau tool? The traditional BI, Tableau and BI architecture has a hardware limitations. Okay, Tableau does not have a dependencies. It does not support in-memory, multi-thread and multi-core computing. It supports memory when using advanced technology. It has predefined view of data. It uses predictive analysis for various business operation. We should need a good knowledge of BI and skills. It is easy working and understanding without the knowledge of BI, and the skill data security is provided. Data security is not provided for a public, whereas in the professional version. So these are the things we have with respect to the traditional BI and Tableau. Next question we have: define performance testing in the terms of Tableau. We can check performance of Tableau in the two ways. Okay, so first one, we can create the performance recordings to keep the track of performance detail of our main events while interacting with the workbooks. Then these performance metrics can be viewed by the user and analyzed. Navigation to start stop performance recording, we can go with the help, then setting, then setting and performance, then start performance recording. Okay, so these are the steps you have to follow in order to enable the performance checking in the Tableau. Then we have to just review the logs created by the Tableau desktop. The location for the log is C users my document, something like that. Tableau repository, we can find that log file. Then for the live connection, if you have a live connection, check the log file in the log.txt in the Tableau proto server.txt. Okay, and for extract connection, check the log file in the TDS server or TDE server.txt. Okay, so these are the things we have with respect to the performance monitoring in the Tableau. Okay, next question we have for the day: what is the difference between .twb and .twx extension? Okay, so .twb means Tableau workbook and .twb is an XML sheet. It stores the data about your documents, stories and dashboard. The file is the reference to the source files such as Excel or TDE. This file will be linked to your source file when you save the .twb file. If you want to share your workbook, you need to send both workbook and data source file. On the other hand, .twx, it is a compressed file where you can have all the files. It includes data source file, twb and other files to produce the workbook. .twbx is a absolute for sharing because it will share a copy of the file instead of the original file. .twx is used for reports and we can view using the Tableau viewer as well. Okay, next question we have for the day: so why Tableau? Okay, Tableau is a very simple and user friendly. Next, Tableau helps in analyzing the data, and using this one can change the raw data into an understandable format. Then users can blend the data with the other data to create their own views on the data and to share it with the customers and colleagues. Users can manage a large amount of data. It can easily integrate with the multiple data sources. Tableau can create the complex graphs which simply looks like a pivot table graphs in the Excel. It gives a quick calculations on the data set. Users can create a visuals easily and switch between the types to find the model to represent the user messages. Clear? Okay, so these are the things with respect to the why Tableau and why should we use Tableau. Next question we have for the day: how to create a calculated field in the Tableau. Okay, so if I want to do some calculations, for that we need some calculated field to integrate into the visuals, so to do some dynamic calculation. So to do that, first step is that select analysis, go into the drop down, it will open, then select and create calculated field. Once it created, then you can go into the calculation editor box, and in that field you can just enter your calculation, something like sum of profit divided sum of sales, and then just click OK, and the calculated field is now available into your field pane. Clear? Next, are there any limitations of parameters in the Tableau? If yes, give the details. Okay, Tableau dashboard allows the representation of parameter in the 4 ways only. Okay, they don't allow any multiple values like a filter can do. They only allow a single value. So this is the basic limitation with respect to the parameters in Tableau. So they can only hold a single value, or the value or single value which is changing over the times. So it cannot handle the multiple value as like a filter. Okay, next question we have: state some reasons for low performance in Tableau. Explain in detail. Okay, following are the reasons for the low performance. First one is filter. Filters need to create an extra query, and if it is uses in a large number and inefficiently, then they can produce the performance. So it is advised to use the filters whenever it is mandatory. Okay, then there is a live connection. Tableau extract works much better in the compression with the live connection. Okay, then there is a data source. Okay, then there is a data source. We have a wrong query to a wrong data source can reduce the performance. Also the data source performance can also affect the Tableau performance. So these are the some of the things with respect to the low performance in the Tableau we have. Clear? Let's move towards the other question we have: state some ways to improve the performance of a Tableau. Okay, let's see. Following are the few ways to improve the performance. Okay, first, use the extract to make workbooks run faster. Then reduce the scope of a data to decrease the volume of a data. Then reduce the number of marks on a view to avoid information overload. Then we can do just like try use integers or boolean in calculations, as they are much faster than the string. Next, hide the unused field. Use context filters. Then reduce filters uses and use alternative ways to achieve the same result. Then we have a use indexing in table and use same fields for filtering. And next one, remove unnecessary calculation in the sheet. So these are some of the ways we can just improve the performance of Tableau. Okay, so these are some of the questions we have for this session, and we'll stop for here, and we will again meet one some another interview question with respect to the Tableau. Till then, goodbye.